All right, well, I trust you did as well on your test as the students in here did. Did very, very well on their tests. Unfortunately, no perfect in this classroom, though, Scott, I haven't gotten your test back yet, but hopefully by the time you're watching this, you've turned it in. I did get a perfect from one of our 8th graders, so no pressure, but and a couple of people in here were really close, so I think we're going to start having some perfects on the wall here pretty soon. Anyway, before the exam, I had talked to you about multiplying polynomials together. Obviously, that was not on the exam, but I want to review over that. So take your notes out if you would, and I want you to write this problem down and work it along with me. And you might remember working problems like this before the exam. Like a polynomial such as 2x plus 1 multiplied by another polynomial, 3x negative 5. And we said just like 2-digit multiplication or multi-digit multiplication in arithmetic, we're going to start just 1 digit multiplied all the way through, then the next digit all the way through, except that in algebra we work this direction. We work from left to right. So instead of starting here and multiplying all the way through, we're going to start here and multiply all the way through. But it's still going to be those same 3 steps for multiplication, class. Sign, number, letter. So we're going to start with the 3x times the 2x, class, to get
6x squared.
There we go. Don't forget 3 times 2 is 6, but x times x is x squared. And then we're going to multiply the 3x by the positive 1. Positive 3x. And then remember in multi-digit multiplication, we had to put a 0 as a placeholder to shift our digits so they would line up with correct place value. Well, here we shift this way. You don't necessarily have to draw the little half box. I do just to help me remember to shift over. And then we're done multiplying the 3x. So now we're going to multiply the negative 5, again, all the way across left to right. So negative 5 times 2x.
Negative 10x.
And negative 5 times 1.
Negative 5.
So don't make this hard. Anything times 1 is itself. Brains are fried from the exam yesterday. And then we're going to add the partial products together, remember. Well, again, this isn't a column by itself, so we just get
6x squared.
And then here we've got some combination to do.
Negative 7x.
And of course we've got the negative 5. Do we remember doing this before the exam? We're like, oh, I forgot all about that. All right. Most of you, Dylan's like, huh? No, Dylan does remember. Okay. How about this one? Write this one down. 4x squared, negative 9x, positive 3. We're going to multiply this by a negative 2x, positive 6. I want to point out, by the way, that if you have descending order in your factors, such as we see here and here, it's going to help things to line up properly in the partial products. Let's start with Adam. What do I need to do first as we multiply these two polynomials?
Multiply the negative 2x by 4x squared.
Good. To get?
8x cubed. Or negative 8x.
Negative 8x cubed. There we go. Sign, number, letter. Then what will we do, Lana?
I feel like you go across somewhere.
Mm-hmm.
Negative or positive 18x squared.
Good. We could just keep working our way across. We're going to multiply this here, here, here. Just multiplying across here. So then our next multiplication is going to give us what, Joshua?
Negative 6x.
Negative 6x. And then we're done with the negative 2x. There's nothing left to multiply it by. So what then, Dylan?
Put like that half box thing, and then multiply 6 by 4 to get 24x.
There we go. Now we're going to multiply the 6. And again, same thing. We're going to go all the way across. So we start with the 4x squared. Then we're going to multiply it by the
Negative 9x.
to get.
Negative 54x.
And then class, we're going to multiply it by the
3.
to get 18.
Oh wait, no.
All right, yeah, be careful. Sign, number, letter, stay focused all the way through. And then we're just going to add the partial products together. Add them to get
8x cubed.
negative 8x cubed.
46. No. 40. Oh.
42x squared, right? 18 and 24. That's to get 42. 8 plus 4, 12. Carry the 1,
right.
1 plus 1 plus 2, 4. Don't forget, keep the x squared. We're adding here, not multiplying, so don't get an x to the 4th or anything weird like that. Also, make sure you include the positive sign, because that's going to separate the terms from each other. Back to Adam.
Negative 100. Wait. Huh?
We got a negative 6, and we have a negative 54.
Oh, I was reading that negative 60 something. But, no. Negative 60. X. Wait, no.
Right, not x squared. You started to say x squared. No, we're just adding, so we're just going to keep the x. Good. And by the way, if it'll help you remember, we should have a descending order here. Cubed, squared, first, gone, right? Descending order should be in our answer as well. If that randomly was an x squared, we'd have really funky terms going here. So hopefully that'll help you remember that. Now, not always does it line up so beautifully. If you've got an unaccounted for variable, for instance, write this down. 2a negative b negative c times 7a positive 8b. Here the c is kind of going to throw things off. Everything else looks nice and neat. We've got a's, we've got b's, we got a's, we got b's, and there's a c. Okay, so it's going to mess some stuff up here, but the process overall doesn't change. Joshua, we're going to start by multiplying the
7a times the 2
to get
14a squared.
Keep going.
Negative 7ab
Good. Sign number letter.
and negative 7ac.
There we go. Just multiplying the 7a all the way across. Now, normally, class, we'll shift over, and let's now multiply, Lana, the
7, 8, or no, the 8b.
the 8b gets multiplied by everything. We
Yeah,
can
I was
scribble out the
thinking-
7a if we want to. And what do we get?
16ab.
There we go. Notice it lines up nice and neatly. But when we multiply our next thing to get
Negative 8b squared.
that doesn't line up, does it? So we're going to need to skip over here and put our negative 8b squared in its own column. Does that make sense?
Mhm.
It doesn't line up with the other stuff. And that's, again, the c is what kind of throws things off here. The fact that there's a c in the top, no c in the bottom, kind of messes with things. Continue.
Then we get negative 8bc.
All right, and then we could add, let's suppose we had like a negative 3c here. Well, we could multiply that as well, couldn't we? Finished? I'll bring it around to the side here. So when we multiply the negative 3c class, we get negative 6ac. And technically, if you shift it over one more time, right? Just like you would if you were multiplying, I don't know, 7,842 times 364, right? You'd multiply the 4 all the way through and get some different numbers. You'd put a 0, multiply the 6 and get some different numbers. Then you put 2 zeros, right? You shift over a second time, wouldn't you? You multiply the 3 all the way through and get some more numbers, then you add them together. The same thing here. We shift over again. We said we're going to get what again?
Negative 6ac.
And notice that is still going to line up here, the negative 6ac. Here we're going to multiply class to get
Negative 3bc.
close. What's my
Positive
sign?
3bc.
Positive 3bc. Notice though, the bc's over here in this column, isn't it? So I'd have to go put the positive 3bc way over there, and then here we multiply to get
Positive
c
3
squared.
c
positive 3c squared. And that's going to have to get its own column because there wasn't already a like term. Okay, so again, the presence of the third variable sometimes can make some things messy. Just keep things neatly organized in your partial products, and then add 14a squared plus nothing.
14a squared.
Negative 7ab, positive 16ab,
9ab.
positive 9ab. Negative 7ac, negative 6ac.
Negative 13ac.
Of course, the negative 8b squared has no friends. The negative 8bc, positive 3bc.
Negative 5bc.
And of course, the positive 3c squared at the end also has no friends. A big ugly answer, right? Questions on this process of multiplying polynomials together? Questions on that? All right, take just a moment to copy it down.
Will we have stuff like that?
Of course. Not on the exam you didn't, but you'll have it on the next test.
Oh.
Oh.
Now, here's the deal. With this multiplication, right, couple things. It seems rather complex, right? And also, it's a pain to write things that way. So a much easier way would be to write, for instance, a polynomial in parentheses and then another polynomial in parentheses side by side. This means the same thing as if one was underneath the other, right? But the parentheses up against each other still means multiplication. Well, let's suppose, class, it didn't say x plus 2. Let's just say it said 2. How would I multiply a 2?
Distribute.
Distribute, right? And we're really good at distribution by now. We've done a lot of practice with it. Let's suppose it just said x. What would I do?
Distribute.
Distribute. We can do something called double distribution, where I'm going to ignore the existence of the 2 for now. We'll come back to it. And just distribute the x. sign, number, letter. What do we get when we distribute the x, Dylan?
X cubed positive 3x squared negative 7x.
And then we're going to ignore the x and distribute the 2. And when I do, I am still going to shift over. And when I distribute the 2 all the way through, Adam, I get?
2x squared positive 6x negative 7, not 14.
There we go. And then we'll still add our partial products to get the x cubed, positive 5x squared, negative x, negative 14. And I feel like this may be an easier way for you to see it, because you're good with distribution. It's no different than what we were doing there. We were essentially taking the 7a and distributing it, weren't we? Then we went to the 8b and distributed it. We went to the negative 3c and distributed it. But seeing it side by side may help us to see the distribution a little bit better. Write this one down if you would, please. 3x, negative 4, times 2x squared, negative 5x, positive 1. And Lana, what do we do first?
Distribute 3x.
Good, and when we do, we need to ignore the existence of the
Negative 4.
negative 4. Again, don't try to distribute the 3x into the negative 4. We're distributing into the other polynomial. So ignore the negative 4. Lana, what do we get as we distribute?
6x cubed, negative 15x squared, positive 3x.
Good, and then what, Josh?
Distribute the negative 4.
To get?
Negative 8x squared, positive 20x, negative 4.
There we go. And we just add the partial products together to get what, Dylan?
6x cubed, negative 23x squared, positive 23x, negative 4.
And there we go. Does it seem a little easier seeing it as double distribution? My personal sentiment, I feel like this is easier as well. I wanted to show the other when I taught it because it has its roots in, if you will, the multi-digit multiplication. It's set up the same way, essentially. That explains the shift, it explains the one number at a time kind of thing, but I feel like the actual execution is going to be easier if we treat it like double distribution. Page 198 in your textbooks, I want you to do 3 of these, and you can do whichever method you prefer. If you like the vertical stack better, more power to you. Probably, it seems like most of us prefer the double distribution, but your choice, 1, 3, and 5 on page 198, there at the top of the page. Take just a few minutes to work these 3 problems. Be careful with every sign, every number, every letter. Well, for sake of time, let's go ahead and take a look at these together. On number 1, when you distribute the x, check your first partial product. So we got an x cubed, positive 3x squared, negative 4x. Then we should have shifted and distributed the 1, which of course just gives us x squared, positive 3x, negative 4. Add them together, should have got an x cubed, positive 4x squared, negative x, negative 4. How many had this answer for number 1?
Yeah.
All right, questions? Check your partial products if you didn't get it.
I got it.
Let's take a look at number 3. Should have distributed the 2x to get a 2x cubed, negative 12x squared, negative 4x. Then distributed the 3 to get a 3x squared, negative 18x, negative 6. Combine everything to get 2x cubed, negative 9x squared, negative 22x, negative 6. How many had this answer on number 3? All right. Good, all right. Then number 5, we have 2 letters we're dealing with, so there may be some irregularities. Let's see. We distribute the x to get x cubed, positive x squared y, positive xy squared. Then shift, distribute the y to get an x squared y, positive xy squared, positive y cubed. Hey, everything lined up nicely. That's awfully nice. Get an x cubed, positive 2x squared y, positive 2xy squared, positive y cubed. And how many had that answer on number 5? Or perhaps you say, I was on the right track. I was finishing it up and all my partial products were correct. Any questions at all on this double distribution thing? All right, number 7, if you'll go and write that problem on your paper, we'll work it together. There is going to be a little bit of irregularity on number 7. And the reason you see that, remember I keep emphasizing descending order. Notice that the first polynomial is descending, right? You go from x squared to x to the 0 or x gone. But there's no x to the first power. And that's going to throw some things off here. So we got our x squared minus 1 being distributed to the x squared, positive 3x plus 4. What do we get when we distribute the x squared all the way through, Adam?
X to the 4th, positive 3x cubed, positive 4x squared.
Good. What do I get when I distribute the negative 1 all the way through, Dylan?
Negative x.
Negative 1x squared is going to come all the way over here. Do you see that? Then
Negative 3x. Negative 4.
do you see, class, that it's as if, because I went from, instead of squared power of x to first power of x, or first power of x to the 0 power of x, I jumped 2 spots in the x power. Does that make sense? I went from a squared to a 0 power. There's 2 places of shift. This is kind of like if you had to take you back here, if you had like a 734 times a 504. Your teacher taught you multiply the 4 all the way through. And if there's a 0, instead of putting 1 0, put another 1. And then multiply the 5 to get this. But putting those 2 zeros to start out can shift you over where you belong, because it's not a 50, it's a 500, so we need 2 zeros. Well, that's because we skipped the units digit. We skipped the first power of x, so hence a double shift over. So very, again, analogous to arithmetic, if you would. And then when we add the partial products, the addition's really easy. Lana?
X to the 4th positive 3x cubed. 3x squared, negative 3x, negative 4.
There we go. And the only place we had to do any addition at all was that middle column there. Questions on number 7. Questions on 7. All right, write this problem. Oh, yes, sir.
The answer to that one is 369,936.
Correct. Yep. All right.
You
So,
actually took the time.
well, I mean, there's not, the only addition you have to do is right here, right?
Oh,
Again,
okay.
kind of like here, there's only addition in 1 digit worth anything. Here, there's really only 1, technically 2, because this was a 20, it just happened to end in a 0. But you knew these were going to be standalones, and these are standalones. And by the way, it's a palindrome. Oh, not quite. That would be a 6. That'd have to be a 6-3, wouldn't it? Never mind. It's like 369,963. Never mind. No palindrome. All right. Just excited about it. All right. Write this down. X negative 2 times x cubed positive 10 negative 7x positive 4x squared. You can work the problem as written, but I don't want to. Because it's going to be a mess trying to keep track of all my like terms and keeping things lined up and all that nonsense. Things are much easier if we arrange in descending order first. Write that in your notes. Get descending order first. Now the x minus 2 is already descending. Do you see I have an x and then I don't? That means it's getting smaller, right? But the other polynomial, the big polynomial, that is not in descending order. How should I rewrite this multiplication problem to have descending order, Joshua?
X cubed. Positive 4x squared, negative 7x, positive 10.
There we go. And now we see the x is going smaller. Cubed, squared, first, gone. And of course here, the x minus 2 was not an issue. And now we can distribute. Joshua, keep going. Distribute for us.
X to the 4, positive 4x cubed, negative 7x squared, positive 10x.
There we go. And then the next half of the distribution, Dylan.
Negative 2x cubed, negative 8x squared, positive 14x, negative 20.
And then adding everything together, Adam.
X to the 4th, 2x cubed,
Positive 2x cubed.
negative 15x squared, positive 24x, negative 20.
There we go. And again, easy because everything lines up nicely when it's in descending order. Had it not been in descending order, it would have been a mess. Write this one down. 2 plus a times 4a squared minus 2a cubed minus 8a minus 3. Lana, how should we rewrite this multiplication problem?
8a cubed, wait, 8a squared. Wait.
I just want to rewrite it, Lana, because we want to get descending order first. I'm not ready to distribute yet. I just want to get descending order first. And it ain't in descending order, is it? Now, them A's ain't getting smaller. Let's make them A's get smaller.
4a squared, negative 2a cubed, and then negative 8a positive. Or no. Wait, what?
Lana, what's the biggest A we got?
4a squared.
No, it's not.
I mean, no. Negative 2a cubed.
Negative 2a cubed. So we're going to start with the negative 2a cubed. Then,
4a squared.
there we go, positive 4a squared.
And then negative 7? No.
Where'd you get a 7 from? Lana.
7, I combined the A's.
No. We ain't got nothing to combine.
8a?
Negative 8a.
That's, negative 3?
Look, Lana, the a is cubed. That's big, that's powerful.
Oh.
A is squared. That's a little
I
less
just tried to
powerful.
distribute. Oh.
This is first power. That's even smaller.
Okay.
This is 0 power. That's the smallest. Well, until you get in
I'm
negative.
just trying to distribute.
No, don't do that, Lana. Just get it in descending order. Now, Lana, what about the first binomial? Is this descending order?
Yes.
So we got no A's and then we got 1A. That's getting smaller?
No.
No, it'd be smaller if we had
A
1A and then we
plus
had
2.
There we go. We'll just flip flop and say A plus 2. So now we got A1A, we got no A's. That's getting smaller. Now we're ready to distribute. Lana's been excited about this for a while now. Lana, go ahead and distribute for us.
Negative 2a to the 4th, positive 4a cubed, negative 8a squared, negative 3a.
All right, keep going.
Negative 4a cubed, positive 8a squared, negative 16a, negative 3. Wait, no, 6. Yeah, that's what I meant.
All right, then we add these all together. What do we get, class?
Negative 2a 4, negative
negative
6.
19a,
No,
negative 6.
negative 19a, negative 6.
Yeah, these a cubes cancel, so do the a squares. So we are left with a trinomial. Negative 2a to the 4th, negative 19a, negative 6. Now, if you were writing this in the blank on a test, you wouldn't have to leave a huge gap, right? You could just write it like that, okay? But there we go. It's something a little unusual, right? With inverses canceling in the partial products. Questions on this? All right, your turn to try one of these. Write this one down there at your seats. We want to take an a negative 5 and distribute that to an a cubed, negative 30, negative 4a squared, negative 11a. Did you rearrange it in descending order?
Mm.
Oh.
Well,
Oh,
I did. I
Oops.
was just.
I mean, yes.
Yes, I did.
I should have taken a moment to get this first, then you could do your double distribution. And check my answer. Did we get the same thing I got? Dylan did.
Almost did.
Adam went, oh. What's that? What's that?
I'm just checking what I did. See what I did. That's what I did, right.
Alright, which one? Where'd you make the mistake?
Wait, where's
I just made accidentally read an imaginary negative mark at the a to the 4th when I multiplied it with negative 5. And I got like a negative, no, I got a positive.
Oh, positive 5a cubed right here.
That's what I did.
Okay. Alright, careful there. Any other questions, comments on this?
I don't know. I did it right.
Scott has a
I did it right, I think. I just didn't add it yet.
Scott has a question.
Well, you didn't do your
That's
distribution
probably-
yet.
I put it in descending.
Right?
And then
You distribute the a all the way through, and then you distribute the negative 5 all the way through.
Yep, I got it now.
Let's take a look at number 11. Copy number 11 down on your paper. We've got an x positive 4 being distributed to x to the 4th, negative x cubed, negative x squared, positive 5. Does anyone notice something missing?
There's not another x.
There's not an x to the first. There we go. 4, 3, 2, gone. We skipped the x to the first. So just realize there's gonna be a little something weird that happens, okay? Be ready for it, but technically it is in descending order, right?
Yes.
So we can go ahead and multiply. Let's start by distributing the x class.
X to the third, negative x to the 4th, negative x cubed, positive 5x.
All right, and then we're gonna shift over, and now let's distribute the 4. Class,
Positive 4x to the 4th, negative 4x cubed, negative
4x
4x
squared. Wait,
positive 20.
wait.
and you see here there wasn't a place for the x squared, because here we kind of have that jumbled gap, and then here there's not. Do you see that? It's just a little weird here at the end. Okay, everything lined up great to begin with. The 5th, the 4th, the cube, but as soon as you hit the square, there's a square here but not a square here. There's a first here but not a first here, right? Just a little something weird because there's a gap in the x's. But the first 3 columns add really nicely.
X to the 5th, positive 3x to the 4th, negative 5x cubed.
Now we'll take the only x squared we've got, which is the negative 4x squared. Let's take the only x we've got, which is the 5x. And then the only number, which is the 20. So again, it's something weird at the end. Weird things happen when there are gaps in the x pattern. Does that make sense? Just something to watch for. Look at number 13. X plus 3 times x minus 1 times x plus 2. Whoa, wait a second. What are we doing here? Well, on something like this, you pick any two to multiply first. My preference would be take the last two and multiply them. So let's keep our x plus 3 for a moment, because you can't multiply more than two things at once anyway. Let's multiply the x minus 1 and x plus 2. So let's double distribute the x.
X squared, positive 2x.
And then the negative 1.
Negative 1x. Negative 2.
Try not to sound so excited, Lana. And then we add those together to get?
Squared.
Negative 3.
Careful. Signs are different.
Negative x.
Positive x.
Positive x, keep the sign of the greater.
Yeah.
And now we can distribute the x plus 3. So now let's double distribute. Take the x all the way through.
X cubed positive x squared negative 2x.
Take the 3 all the way through.
3x squared positive 3x negative 6.
Yeah.
And then add those partial products together.
X cubed positive 4x squared positive x negative 6.
And there we go. So even if there's a chain, now again, you don't want to do too many of those, because let's not be crazy, but even if there were a chain of binomials or something, you just take two at a time, right? And double distribute one, then the next. For instance, look at number 15. We're not going to take time to do it, but notice how you have a binomial cubed. Well, that'd be 3x plus 4 times 3x plus 4 times 3x plus 4, right? Multiply. I would start with the back two. That way you have the 3x plus 4 sitting in the front. You can double distribute in the second step. Anyway, for homework this evening, you're going to do page 198. Practice 2 through 16 even. Page 198. Practice 2 through 16 even. And page 110, review 13 and 14. It's a couple of word problems. Page 110, the review numbers 13 and 14, the word problems. They're on page 110. So one more time, page 198, practice 2 through 16 even. Page 110, review numbers 13 and 14. We'll continue working on this in our next lesson. Have a wonderful rest of your day, and you are dismissed.